Here we've got average value of function question. So say we are to find the exact average value of this particular function over this interval. So we know the average value of function follows this equation, that is, over interval going from a to b, notation goes as b minus a of this entire value divided by the thickness of this interval. So a to b of whatever the function is with dx. So this is a typical expression for average value of function. So let's try to find this. If average value of function is going to be then going from before the integral 1 over 8, because 8 subtract by 0 is 8, so we need to divide it by the thickness of this interval. The total area of the function that falls over this domain. So 1 plus square root x to the power of 3, this is 1/3 dx. Whenever you see this kind of expression where you've got a root function involved and there's no other relationship as so that you can apply chain rule type of a form, then you want to think of substitution. So here you want to let u be this whole thing. It's kind of hard to deal with. So that's x to the power of 1 over 3. This switches our relationship as we multiply both sides to the power of 3, u to the power of 3 becomes x. So how do we deal with dx? It's simple. Do not try to deal with it from here. Do it as you apply derivative to both sides. So you have 3 u to the power of 2 du is equal to dx. So wherever you see dx, you can replace by this expression on the left side. So this will then equal to 1 over 8 integral. The thing to be careful when you use substitution is that you need to also change this interval, because these correspond to variable x. Now we're going to be dealing with variable u. So everything has to match to variable u. So then when x is equal to 0, based on this relationship, we know that u is also going to be 0. 0 to the power of 1 over 3 is still 0. When x is equal to 8, which is the upper bound, 8 1/3 raised to the power is going to be 2. Because 8 splits to 2 times 2 times 2, power 1/3 means you want to take 1/3 of it, which is just 1/3 of it. That's just 1/3 of 2 to 2, that's 2. So our interval will go from 0 to 2. This is very important that you want to align everything together to match with variable u as you do substitution. So we have denominator first, 1 plus u here. The top should be 1, but we have dx. dx is now equal to this, so you want to write 3 u to the power of 2 du. So this 3 has nothing to do with variable u, it can come out to the front. So we have 3 over 8, integral going from 0 to 2, u squared over 1 plus u du. Now we've got a rational function, so you want to do long division. So as we do long division, we have u to the power of 2, we are dividing by, we can switch the order, so it's easier for us to do this. So you want to find the quotient because we're applying partial fraction. So you have u as the quotient, which is u squared plus u, subtract, that gives negative u, negative 1, then negative u, negative 1, then you have 1 as remainder. So this expression is going to change to be written as 3 over 8 going from 0 to 2. You put the quotient first, so this thing is now going to equal to u minus 1 with plus 1 over 1 plus u and the entire thing du. This one is much easier to do. Take the integral now. So 3 over 8. Then let's just go ahead and take the antiderivative. So this will be u to the power of 2 over 2 minus u. That will be simply ln 1 plus u, and that goes from 0 to 2 in close bracket. So this will be 3 over 8. As we plug in 2, we have 4 over 2 minus 2 plus ln, we don't need absolute value because it's all positive. We've got ln 3, and then subtract by, this will be 0, this will be 0. As you plug in 0, ln 1 is equal to 0. So then we have 2 minus 2, which will cancel itself out because that will be just 2, 2 minus 2, so this whole thing will disappear. Don't cross it out on the exam paper, I'm just doing it to show you that we don't need to deal with this anymore. So we have 3 over 8, only ln 3 left. the way you can change this, you can leave it at that, but also another thing you can do is this switches as 3 times ln 3 over 8, so the power can be tagged on. That's what happens with ln. The power can be tagged on here. So this can change to ln 3 to the power of 3 over 8, which is ln 3 to the power of 3 is 3 times 3 is 9, 9 times 3 is 27 over 8. So it is safe for you to leave your expression this way, but if you want to simplify further, as opposed to 3 components down to 2 components, then you can bring it up to here. So this is what it means to deal with average value function, basically the area under the curve over this domain, and then you want to divide by the thickness, which is the width of the domain, to find the average value, which is the y value going from in this interval. So you put the function in. You want to make sure to divide by the thickness of this interval, which is this. So this is very important. Don't forget to do that as you're dealing with average value function. Make sure that you put it at first before everything else. And as you apply method of substitution, we apply actually 2 techniques solving integral, which is substitution method, as well as partial fractions. So this involved using long division, where you can change a rational function into a quotient and remainder form. So that's quotient, and that is remainder. So it's easier for us to take the integral. So these are various techniques. So I hope that as you watch through this video, that this reminds you that there were these techniques out there that you use all the time as you work through the integrals. So basically, as you feel comfortable with various techniques, then the rest is just solving through the integral. And then at the very last step is just numeric computation.